Good afternoon, good evening, good night, depending on where you are in the world. If you don't mind, you can leave your location in the world on this beautiful day for physics. You can just say where you happen to be, and then we will get started. So today, dimensional analysis. So thank you and welcome from Paris, France, and Sydney and London. So across Europe and Ireland as well, and across Australia, Melbourne, Queensland, Sydney, and coast to coast to coast. Okay, so today we're going to exercise a very, very important muscle in your mind, and this is called dimensional analysis. And it's the being very, very careful with units, and it's going to teach you a insane sounding skill, which is that you will be able to get some answers correct on the real exam without fully understanding what the question is. This is real. I'm talking about the real GAMSAT. You'll be able to get some questions right just because you are following the units and you're careful with the units. So we're going to develop that skill. So we will be doing practice questions, time practice questions, but first a little bit of warm up, a little bit of perspective. So of course, this is one of the new Master Series books, and I'll just underline a couple of things at the start for you. The level of physics that you require. This is for most science topics, it's first year undergraduate level. For biology, which is 40% of the exam, general and organic chemistry, 20% each. But for physics, which is 20% of the Section 3, it is more A levels, leaving certificate, grade 12 level. So basically high school, secondary school level physics. It's not advanced at all. Most students would agree that most of the physics on the exam is going to be equation manipulation, graphs, tables, diagrams. And so it's mathematics. Your basic skills from secondary school or high school to complete calculations, that has to be seamless. And you're not just doing it because you want to get a good physics score, but it's also because most general chemistry and most biology is graphs, tables, diagrams, and equation manipulation. So that's why you're doing it. So this is approximately 20% of your Section 3. And of course, Section 3 is 1/3 of your exam. And depending on which program you're applying to, 1/3 might be 1/3 of your score, or it might be half of your score, where 50% of your score is science and 50% of your score is non-science. Depends on where. Now, this is a little summary of what students have said when sitting GAMSAT. I'm just going to be quiet and let you read that. Okay, I think that gives you a little bit of perspective of what to anticipate so that you don't waste time. A lot of people, they're not comfortable with physics, so they spend a lot of time trying to memorize useless information. Now, if you happen to have the book, great. If you don't, it's okay. You can get the information online. But the most important chapters are the chapter that we're going to be talking about right now, which is dimensional analysis, and the graph analysis chapter. Those are the most important ones. And when it comes to dimensional analysis, you need to know what your dimensions are. And dimensions are the ways that you measure something. So, for example, here are the SI base units. The SI system, or Système International, is the basic measurement system that is used for GAMSAT and for science in general. And if ever anything else is used, they'll always give you the conversion factors, but you're expected to know this. And these are the basic units, and there are derived units here, and then there's units with special names and symbols, like the Newton, which we'll be talking about for force a little later, and for energy, work, and quantity of heat, it's all the same, and that's the joule. And the joule is also known as a Newton meter, which is force times distance. And we will also be talking about that a little later. You're also expected to know the conversion factors for just the basic SI system. So, for a tera, giga, mega, kilo, of course, you hear about that a lot in science, deci, centi, milli, micro, nano. So you hear about those, and you're expected to know those conversion factors at a minimum. And yes, so this famously is the concepts of how do you apply dimensional analysis? Well, it's by recognizing the many, many different ways that you can write the number one, because you know intuitively you can multiply anything by the number one and it doesn't change, right? You have the number 55, you multiply it by one, it's still 55. So you can multiply anything by the number one and it's not changed. Well, the magic of dimensional analysis is that you can get a conversion factor where you know intuitively that 1 hour is equal to 60 minutes. So you could put 60 minutes in the numerator and the 1 hour in the denominator, or you can do the reverse. It's always the number one because 60 minutes is 1 hour. They're both equal. Now, why is this so powerful? Because sometimes you're going to be in a situation where you're going to multiply something by 60 minutes over an hour, but in a different problem, you'll multiply it by 1 hour over 60 minutes. How would you know what you multiply it by? It depends on what you start with and where you're going. Because if you have an hour in the denominator, then if you're multiplying it by something that is hours, don't worry, we're going to try this in a minute, then the hours cancel and you end up with minutes. And so vice versa. So it depends on what are you trying to convert to what that allows you to know what you put in the numerator, what you put in the denominator. But you are expected to know a certain series of conversion factors. Of course, some of them are intuitive. You've always known them. You know approximately how many days there are in a year. You know how many hours there are in a day and how many days in a week. And those simple conversions are often used on an exam, on a GAMSAT, in order to convert something to something. Okay, so, we're going to do some real questions, but first, I just want to make sure that you have the right perspective. Okay, so I'm going to ask you to, I know you're going to feel, and some of you will feel insulted that I ask these questions, but I'm going to ask just two very basic questions. We'll get that done, and then we'll go on to GAMSAT level practice. So first question, apologies in advance, but please just be the first to do it. Don't use a calculator, but be the first to put in the chat how many days there are in 3 years. And no matter what, please do the calculation. Even though it's so trivial to you, it's so ridiculous, just we'll get to something more important shortly. So how many days are there in 3 years? Okay, so it looks like we have many similar results. Oh, and I love Smatav's solution. He gave an estimate, which is great because you're only going to be as specific as you need to be on an exam. So my question, how many days in 3 years? So we're given 3 years, apologies in advance, but we're going to get to something more important. So we're given 3 years. And what we do know is there's 365 days in a year. So that's It's actually approximate, but that's good enough. So we have 3 years, and I've asked for the number of days. So the first thing I want you to see is that this is how you set up dimensional analysis. You start with, what information do I have? What information am I seeking on the other side? And this is going to be an equality. I want unequality. I want to be specific about that. So you want 3 years to be equal to a certain number of days, So here's where I apply my conversion factor. This is the dimensional analysis. So I know that I have years in the numerator. So I want to cancel years and end up with days. So I want to multiply this by a conversion that will have years in the denominator and days in the numerator. And then years will cancel, and then I'll end up with days. I know for most of you, you just did it in your head, but wait, it gets more complicated. So it's good to have a system so that when it does get more complicated, you don't get tripped up, because Acer knows all the mistakes that students will normally make, and they'll set the traps. So to avoid it, you have your system. Now you only have to make sure this is equal to 1, because you can multiply anything by the number 1. So how do I make this equal to 1? This is the equivalence. There are 365 days in a year. So that's 1. Their years cancel, then I end up with days. Dimensional analysis means that you're being careful with the units to make sure that units are there. Then it's just mathematics. And there's many ways to do this. You can do it as some of you have done, which was not to do it specifically, because it depends on how complex the numbers are. Sometimes the numbers are going to be very complex. Yes, even on GAMSAT, sometimes the numbers are complex because Acer is expecting that you look at the answer choices and then you make relevant approximations. So we will practice that. But so right now, I just look at this and it depends on the answer choices as to what I'm going to do. But you can do a normal calculation, 365 times 3, or you can look at this is about 350, and 350 plus 350 is 700. 700 plus 350 is 1,050. I could stop there, which is what some of you have done, which was to approximate around there, which is fine. But I also know it's off by 15 times 3, which is 45. So yes, those of you who were more specific were accurate at 1,095. And you would do it that way because it's such an easy, simple calculation. Yeah, you would do it this way. But you would also look at the answer choices to see how specific you would need to be depending on how complex it is. Okay, one last straightforward one, and then we get into this serious stuff. And so I'll hand out the questions, and then you'll try them. So one more straightforward question. And you can find it. Okay, yes. So I'd like to get from you. Okay, so this is 2.7, and as soon as you have it, you can just put it in the chat. Apologies for that little technical difficulty. Okay, so some of you have already written, but I do want to write something for students who are absolutely stuck. This is 2.7 kilometers in micrometers. And just in case, for those of you who haven't done any science lately, so 1 micrometer is 10 to the minus 6 meters. So that hopefully that will give you a little bit of help. Yes, I'm glad you corrected that. Okay. Okay. So again, I just want to show you the setup for this. And so you would be writing, you're given 2.7 kilometers, you want micrometers, so you have 2.7 kilometers, and you want micrometers in the end, so that's 10 to the minus 6 meters. Now, technically, you're expected to know that 1 micrometer is 10 to the minus 6 meters. So you're expected to know that. Those were some of the conversions that I was showing you before, but sometimes Acer is very kind and nice and gives you extra details. Okay, and now, if I know about micrometers and meters, okay, I have 1 micrometer is a meter, so this is the number 1 again. 1 micrometer is 10 to the minus 6 meters. So this is the number 1. I could put 10 to the minus 6 meters over 1 micrometer. It depends on what I'm trying to cancel. So, but I know that a kilometer or kilometer is, kilo is 10 to the 3. So it's 10 to the 3 meters. Kilo is 1,000. So this I can rewrite as 10 to the power of 3 meters. And so if I have meters in the numerator, meters in the denominator, these cancel, and this allows me to get micrometers in the end. So that would be the reason that I choose to go 1 micrometer over 10 to the minus 6 meters instead of vice versa. And when I have this, then if you have, I know for some of you this is child's play, but if you have an exponent which is negative in the denominator and you want to bring it up, well, anytime you bring up the exponent, you change the sign of the exponent. So it's 10 to the minus 6. In the numerator, it will be 10 to the power of 6. 10 to the power of 6 times 10 to the power of 3 is 10 to the power of 9. And then we have 2.7. 2.7. So first we did the dimensional analysis to make sure how things would cancel. And then it's just mathematics. So bringing 10 to the minus 6 up to 10 to the 6 times 10 to the 3, you add the exponents when they have the same base, and then it's 2.7 times 10 to the 3 micrometers. Okay, that's it. That's all. Now you get the real deal. So now we're going to do 5 just very typical dimensional analysis type questions that you could expect to see in some derivation on the exam. Take the I was going to say solve the problem any way you can. If you have a book in front of you, if you want to do some search online, if you want to get ChatGPT to give you a hand, solve it anyway. It's more important that you go through the steps than you just look at the work solution. Okay, but we'll do it together afterwards. Could you please give the link to the handout? So we're going to have 7.5 minutes to complete 5 questions. So you'll have 5 questions, 7.5 minutes. Now, technically, on the real exam, which changed 3 times during the pandemic, and that's no exaggeration, from paper to computer-based, from 1.5 minutes per question in section 3 to 2 minutes per question in section 3. I mean, there are a lot of significant changes that occurred. But nonetheless, you will really have 2 minutes per question, but usually there's a passage first, and that'll slow you down. So these 5 questions are more discrete, And because of that, you have 1.5 minutes per question, and then we will discuss it. Also, I'd like to say about these 5 questions. So don't worry, it's open book if you can figure it out, anything, okay? But over here, I'm going to put some hints, okay, during those 7.5 minutes for questions 3, 4, and 5. So I'm not putting any hints for the other ones, but for questions 3, 4, and 5, I'll put some hints. Don't look at the hints if you're a science student. You should know it, or look at it if you want, basically. But if you don't need them, don't use them. Okay, so if we can get a timer for 7.5 minutes, if anybody has difficulty accessing the file, it starts, the 5 questions start on page 2, so it's page 2 and 3. And if you have any difficulty, just put it in the chat, and someone's going to help you. G or Vivian will give you a hand. Okay, you have 7.5 minutes. Good luck. Okay, so let's get started. And if you do need a little bit more time for question 5 or 4 or 5 later, we'll deal with that later. But let's start with let's begin with question number 1. And what did you choose for your response, A, B, C, or D, for question number 1? Okay, that's quite lovely. So most of you didn't fall into the trap, but a few of you did fall into the trap. Okay, so this is a typical question type in which ACER is not expecting you to know the equation. Some students do know this equation already, but most students don't have this memorized. And so they give it to you and they make sure that you can do a simple manipulation. And yes, as simple as this is to some of you, there are usually 1 or 2 questions like this on the real exam that are just this straightforward. But for some of you, yeah, you fell into a little bit of a trap. So we've got, we're told that diopters is equal to the inverse of focal length. So that means 1 over f, 1 over the focal length. So diopters is 1 over focal length. However, the focal length has to be in meters. So that's what it says. So dimensional analysis means we're going to be paying a lot of attention to those units. So we have 1 over, and we are given 0.5, but that's 0.5 centimeters. So we know that the conversion for centi is 100th. So centi comes from French, of course, cent, which is 100. So this is centi 100th. So 100th is 10 to the minus 2 meters. So this is 0.5 times 10 to the minus 2 meters. Now we've done the appropriate conversion. Then, as I said before, if you have a exponent in the denominator, you want to bring it upstairs, then you change whatever the sign is. If it was 10 to the 2, it becomes 10 to the minus 2 if you bring it in the numerator. If it's 10 to the minus 2 in the denominator, you bring it to the numerator, it's 10 to the 2. And this is 1 over 0.5. 1 over 0.5 is the number 2, right? Because 1 is twice 0.5. So this is 2 times 10 to the 2, and this is diopters. So I did the proper conversion, and this gives me diopters. So this is, of course, 200. And so the answer is D. If you chose B, then you didn't do the proper conversion. And so that would be like a trap on the exam, just a very basic one. Okay. Does anybody have any questions about question number 1 before we move on? Okay, so let's go to question number 2. What did you choose as your answer for question number 2? A, B, C, or D? Okay, this time we're getting more random answers, but yeah, we've got some correct ones as well. We have, but there's more randomness in the answers, but some correct ones, so that's good. Okay, so I know some of you look at a question like this and think, oh my goodness, that's ridiculous. ACER would never ask a question like that. And so every year students go to the real exam and say, they shouldn't ask a question like that. And so there was a famous question they asked for almost 20 years about how fast your nails grow in meters per second. And this I can tell you because they released this question in GAMSAT Practice Test 3. So this was a question students had heard about for many, many years, and was finally released by ACER. So basically, they expect you to make some normal assumptions, nothing that you have to, the kneecap. So nothing that you need to actually memorize in advance. It's just, it has to be just based on reasonable assumptions, and then, of course, dimensional analysis. So what I'd like to do is I'm going to set up the dimensional analysis for you. And just because I know some of you probably didn't do the calculation, and then I'll let you guys complete the calculation, and then we'll complete the response. So in looking at a question like this, I don't know, obviously, what the answer is offhand, but I look at the answer choices and I see they're 100 times different because they are 10 to the power of 2 different from each other. And because of that, I can say they're way far apart from each other. 100 times different. I'm not saying 5% different. I'm saying 100 times different. So it gives a lot of flexibility. So I'm going to take one of these randomly, answer choice A, and I'm going to see what this would give me as a response. And because they're all 100 times different, it'll be easy for me to compare what the other ones are doing without doing another calculation. So answer choice A is 2 times 10 to the minus 7 meters per second. Now, I don't know how fast a person grows in meters per second. I can't relate to that. But I have seen people go from birth to 20, and perhaps you have some experience with that, personal experience with that yourself. At least you have pictures of it. So you know what birth to 20 sort of looks like. And so you can have that concept, and that's sufficient to be able to come to a response. So I know what birth to 20 looks like. So I'm going to convert this into something that tells me what distance to does a person grow up to the year of 20. So I don't know what seconds, so I have to get rid of that. I can get rid of seconds by, I know there's 60 seconds in a minute. So this is that dimensional analysis. This is multiplying by the number 1. 60 seconds in a minute. Why did I put this in the numerator and not in the denominator? Because I want seconds to cancel. I want to know how many meters a person grows in 20 years, not in a second, not in a minute, not in a week. I don't know what that's going to be, but how many meters in 20 years? I could probably relate to that number. So I'm going to multiply it by that. Now I got to get rid of the minutes. So I know the conversion factor for that, 60 minutes in an hour. I know some of you, science students are just thinking, multiply by 3,600. It works most of the time. It doesn't work all the time, because if one time you invert what you're doing in your head, why would you get something easy wrong just because you didn't have the patience to write it out to make sure that everything's canceling? So this is what I would still counsel you to do. And then get rid of the hours, because we know 24 hours are in a day, and then get rid of the days, because 365 days in a year, and then get rid of the years because it's 20 years. And now I will be able to find out how many meters a person is expected to grow in 20 years. And I have confidence in my dimensional analysis, because the minutes cancel, the hours cancel, the days cancel, the years cancel. I know I end up with meters, so I can be very confident in this calculation. It's just a matter of mathematics. I'm going to give you 45 seconds. If you have not done this calculation, please, 45 seconds, please complete this calculation. It's helpful practice. You can put the result that you get for this calculation in the chat. Not for this calculation. What's the result that you get for this calculation in the chat? Hmm. Yes, definitely. You're going to manipulate this to be able to use scientific notation. But I still think that many of you it's just don't have enough experience to do this with efficiency. So let me show you some basic rules as to how to complete these types of calculations. First step, after you have it set up, you look again at the answer choices. Because if the answer choices are very, very close together, then you need to do these multiplications exactly as presented. But if these calculations are far apart, 100 times different, then you start doing estimations. So 24 hours, no way. I'm taking 25 because this is a tiny change compared to 100 times different. It's not like I'm saying estimate 24 as 2,400. It's estimate 24 as something just a little bit different. And 25, obviously, 25 is easier to handle when you're doing a number of multiplications. Here we have 365 days. So no, we're going to take 400. Again, you might look at that as, wow, we added 35 days, but 35 compared to 365 is less than 10%. And the answer choices are not 10% different. They're 100 times different. That's a completely other order. So just changing this by 10% will not affect the answer whatsoever. So, but look at the magic that occurs by making these very simple modifications. I have 25 times 4. 25 times 4 is 100. And then I have these 2 extra zeros. So 1, 2. Okay, so I just converted this 4 times 25, 100, plus the 2 zeros. There we go. Now, count zeros. 1, 2, 3, 4, 5, 6, 7 zeros, 10 to the minus 7, erased. Gone, gone, all gone, and gone. Magic. So what are we left with? We're left with 2 times 6, that's 12. And then that's gone, that's gone, that's gone. We've got 2 times 6. So that's 12. We have 12 times 12, 144 meters. See, Albars, you said 15 meters. It's more like 150. Do you see? You missed just 1 zero somewhere along the line. Does everyone see how those zeros were counted and how we were only left with? Could you imagine this calculation? The hardest part of this calculation is 12 times 12. That's the hardest part of this calculation. Isn't that crazy? And that's obviously 144. So yes, these types of questions, there's literally thousands of questions with all of the books. There's hundreds of them, these questions in the maths and physics book. And also on the website, there's ebooks. And some of these books, by the way, are in local libraries. There are some university libraries and some local libraries that have these books or that will be able to get those books for you. Okay, so we've got 12 times 12 is 144. Did you grow 144 meters from birth to the age of 20? 144 meters? Obviously not. So this is answer choice A. You did not grow the length of a football field in your life. So, but answer choice B would be 100th of this. So answer choice B would be 1.44 meters. Doesn't that sound a little bit more rational? 1.44 meters. So this is the answer. Now, what is answer choice C? Could someone tell me how many centimeters is answer choice C? How many centimeters is answer choice C? Thank you, Nikita, for providing the link to the questions. I completely misunderstood the person's question. Where can I find these questions? Thank you, Nikita. So yes, Janath, it's 1.44 centimeters. Do you see how different answer choice C is? Did you grow 1.44 centimeters from birth to the age of 20? No. So this is the most rational, logical answer. And so even if you hear a question from left field, like really, why are they asking that question? It's going to be based on very normal assumptions. Okay, if no one has any answer, and so you can do this calculation easily in 30 seconds when you use the exponents. Okay, so now we're going to move on to question number 3. And so for question number 3, I gave you a hint, which most people would know, you know, in doing a very, very basic science study, you know, either revision or learning it for the first time, that current is charge over time. Now, why would you know this? Because if someone asked you, what is current? Okay, I guess I should have been, okay, so yeah, I think everybody understood that the answer for the previous one, question number 2, was B as in boy. And now we're on to question number 3, and I've seen some interesting answers so far. So I think most people would know that current is charge over time, because if someone asked you what is current with respect to water, you would say, well, you know, I guess the current with respect to water is the amount of water that is passing per unit time. Because if you have a strong current or fast current, you have a lot of water that's passing for a set given time. And so if you have very slow current, you have a small amount of water passing for that same unit time. So now we're talking about electricity. So when you think about current for electricity, it must be the amount of charge passing per unit time. It's not water. It's not volume of water. It must be the amount of charge passing per unit of time, because electricity is about the movement of electrons. So, so we have charge per unit time, but, and I also gave as a hint what these units are. Current is units of amperes. Charge is in units of C. I didn't say what it is. You don't need to know, but it's coulombs. So it's units of C. And then time, of course, we've seen already, is units of seconds in the SI system. That's why you say meters per second, because those are SI units, meters and seconds. Okay, so now we're given the charge of an electron, and we're given the current, and we're given time. So I know I have current and time. So I can use current and time to get the overall charge, and then we can figure out what the charge on a single electron is. So let's use current and time to get the overall charge. So I have current times time will give me the charge. So the current I'm given is 2 amperes. Okay, and then the time is 1.5 minutes, but minutes is not an SI unit. Seconds is an SI unit, so time in seconds. That's why I put that in the hints. So seconds is SI unit, just like meters per second, as I said before. 1.5 minutes, well, that would be a minute and a half, which is 90 seconds. So we have 90 seconds. And so this will give me my charge, which is 180, and that's coulombs. I have the charge 180 coulombs, but what I want to know is how many electrons there are. So I'm just going to put this as a symbol for electrons. So this is coulombs. I want electrons. How do I get there? I could multiply this by electrons per coulomb. That's one way to do it. Multiply this by electrons per coulomb. And how many electrons per coulomb do I have? You know, this is the same dimensional analysis as we did before. I want coulombs in the denominator. I want electrons in the numerator, and then the coulombs will cancel and I'll end up with electrons. So what is the number one? What is the number one that I can multiply this by without changing it, because this is equivalent? It's 1.6 times 10 to the minus 19 is the coulombs per electron. So this way I can cancel the coulombs, end up with electrons. That's the dimensional analysis. That's what I was saying about before. Even if you don't understand the basic concepts that are involved here, as long as you can follow the units, then you can solve the problem. So now it's just a matter of mathematics. So if we've already done the dimensional analysis, now it's just a matter of you calculating what is 180 over 1.6 times 10 to the minus 19. And if you haven't done that, I'll just give you 30 seconds to do it now. We should be able to finish this seminar within 15 minutes. I think we're on track. So do we have some more people? Because yes, Yuman and Hans, let's see, you got some good answers. Nikita, Albors, you got some good answers, but didn't see a lot of answers. So some people are holding back on the mathematics, but okay, look. So if I were doing this, first thing, again, I look at the answers. The answers are far apart. Again, 100 times different. I don't want to get specific. There's no way on the exam I'm dividing 180 by 1.6. Why would I do that when the answers are so different? Instead, I would do this simple manipulation. I have 180 over 160 times 10 to the minus 21. What did I do? I just moved this over 2 decimal points. If I add 2, I have to subtract 2 from this. You add 2, subtract 2. If I was subtracting 2, I would add 2 to the exponent. But here I added 2 decimal points. So I have to subtract 2 from this, and minus 19 minus 2 is minus 21. Watch what this does. It makes this number approximately 1. And this becomes 10 to the 21 when you bring it to the numerator. Because when you bring it upstairs, you have to change whatever sign there is on the exponent. So this is 10 to 21, and I know the answer is 1 times 10 to the 21. And I just look for something that's close to that. The answers are so far apart. The idea of trying to calculate 1.1 is, and of course, even you just visually could see that this is probably near 1.1 because the numerator is just a little bit more than what the denominator is. So certainly 10% more is very reasonable to estimate. So 10 to the minus 1, that means the answer for question number 3 is A. Any questions about 3 before we move on to questions 4 and 5, which are somewhat related? Okay, so we move on to 4 and 5. And for 4 and 5, I did drop some hints for 4 and 5. These were the hints, just reminding you of some very introductory level equations related to energy and work and force. And there have been exam questions that ACERs have in which these very, very basic equations were implicated in the correct answer. Okay, so for this question, we are given an equation that many students, memorize in undergrad, but ACER would never require you to memorize this equation for an exam. And we're told that this is heat energy, and this is the mass, and this is the latent heat. And so we're being asked, what is the dimensional formula for latent heat? So I'm going to just move this around. I'm going to put latent on the left. I'm going to divide both sides by mass. So I will have Q over M. Yes, thanks, Hans and Nikita, for putting in your answers. Anybody else who wants to add their answers for question number 4, you can just throw it in the chat and we'll soon find out what happens. Now, I have to give you a special warning, especially for students with a non-science background, because this comes step 1. This is something that really frustrates students with a non-science background. And that is, do you see that there's an equation being given, Q is equal to mL, where L is the latent heat, and just lower down in the second paragraph, you're being told that you're going to be converting into the dimensions of mass length, which is L, capital L. We have one question where capital L represents 2 very different things. And this happens on the real exam. ACER had a question once where T was 3 different things in the same question. T was 3 different things. So even well-meaning science students were tripping up on that. And so sometimes when you see that, simplify your life. You know that you're looking for latent heat. Just don't put L anymore because you don't want to confuse it with length, which you also have to do some conversion later for. So there's going to be problems in which you have the same letter representing many different things. And this is also an issue where non-science students are learning science because they see the same letter, and that is just the way it is. You're going to see distance represented as D, capital S, I, L, R, F. I mean, it goes on and on. There's so many different letters that it represents length in meters, but they're very different variables because ACER doesn't want you to be attached to the variable. You're not supposed to. You're not supposed to be attached to F is equal to MA. F doesn't know anything about M and A, okay? F is not equal to MA. It's that the net force on a mass is able to provide us with acceleration. Anytime there's a net force on a mass, there must be acceleration. That's what F is equal to MA means. And so it's more important to understand what does the equation represent. Now here, you just need to understand that latent is energy, and then we have M and L. Q is energy, and then we have M times L. And then we have to keep track of these things as we're doing our dimensional analysis. So here we have Q, that's energy. And all of these different ways are ways to represent energy. This is kinetic energy, famously 1/2 mv squared, mass times velocity squared. This is a potential energy, mgh, this is the height. And this is the work done, which is force times distance. All of these, it's the same units, it's joules in the SI system, and it's all energy. So I can choose any one of these and I'll get the same answer. I'm going to choose 1/2 mv squared, 1/2 mv squared, and that's over m. The m's will cancel. And from a dimensional standpoint, I have v squared. the 1/2 makes no difference in terms of the units. If it's half a Newton or 10 Newtons, that's not what the question is. The question is how many, whether or not it's Newtons. It's just what unit is applying. So the number is irrelevant here. We're not doing a mathematical calculation. It would be very relevant if we were doing a mathematical calculation, but we're just looking at units. And for velocity, we're already given that velocity in the second paragraph is L over T, L over T. So V squared is L squared over T squared. And the other way of saying that is L squared T to the -2. As I said before, bring this into the numerator and you change the sign. And so for question 4, the answer is D. You could have done it any of the other ways, you get the same answer. And of course, you would be expected to know that velocity would be length over time anyway. Velocity is meters per second, it's length over time. Okay, so the answer for 4 is indeed D. Now 5. And for 5, we're given this formula for force is A T to the -1 plus BT squared. So what did you guys get for number 5? And yes, Albros, you can do force times distance. What you would do if you did force times distance in the numerator, force times distance over mass, guess what equation you'd use for force? Newton's second law. So you would use mass times acceleration times distance, mad, and that's over mass, right? And then the masses cancel. You have acceleration times distance. Well, what's acceleration? Acceleration is meters per second squared, L over T squared. And then what's distance? It's L. So we have L times L is L squared over T squared, T to the -2. So you get the same thing. Okay, so we have force is equal to this. And now comes a little bit of logic, using logic. And that is, when you have an equation, this is joules is equal to mass, which is kilograms times latent heat. You can have two things multiplied by each other. These units can be different, and it can give you a different set of units. Different, different, different. But anytime you have units being added to each other or subtracted from each other, they have to be the same units. You can't add apples to oranges. You add apples to apples, you add oranges to oranges. So whatever set of units the force is in, which is newtons, then this has to be in newtons and this has to be newtons. Now, what is A? What is B? We have to work that out. But we know that this has to be newtons because it's being added to this. Okay, so that means let's start with F, the force. The force we can start with as mass times acceleration. So we have mass times acceleration, and we've already worked out what that is. The mass is capital letter M. The acceleration is meters per second squared. So that's meters per second squared. So that's mass is M. Acceleration is meters, the length per second squared. So this is what we have. So let's find out what A must be. A, this must be equal to the newtons. So this is A over T. This is T to -1. So that's A over T. So now what I can do is I can multiply both sides by T to get rid of this T. If I multiply both sides by T, therefore I get, I'll keep it in the same look, is equal to A. Okay, So I multiplied both sides by t, which means I got rid of one of the t's in the denominator here, and then we have this. So ml over t is the same thing as saying ml t to the minus 1. So that means the answer must be D, as in Daniel. But nonetheless, we're going to work out this one because it's trivial. So we've got, again, it's going to be equal to newtons, which is ml over t squared. And that's going to be equal to b over, no, not b over, but b t squared. So this is b t squared. Is everybody comfortable with that? So we've got, I'm just taking b is times squared, bt squared is equal to this, just as we did for a. Now, I need to get rid of this t squared. To do that, I need to divide both sides by t squared. If I divide this side by t squared, that gets rid of that. Then I'll get another t squared in the other denominator. So I have t squared times t squared. That's t to the power of 4. So I get ml t to the power of 4, and that's equal to b. Okay. Any questions about that? Okay. Well, here's the good news. You guys are very early with your preparations. The answer is D. The answer was D for question number 5. It was D for 4 and 5. So you're nice and early. You got lots of time to do many questions like this. If it's your first time doing questions like this, okay, no problem, first time. But after you've completed hundreds of questions like this, then it becomes more of a routine. It's like muscle memory. And that's the ideal thing, that you enter the real exam having completed so many practice questions, all of ACER's questions, all of ACER's practice questions, as many questions you can from various sources. I had a list of ACER's practice questions, but you should know, or should be able, you go to their ACER's website and get their practice exams. They have 5, sorry, ACER has 5 practice exam materials. You should own them. You should use all the questions. I know students complain every year, oh, those questions are not modernized enough. They haven't been updated enough. The exam is harder. It doesn't matter. It helps. It helps even to do questions that are a little bit, a little bit easier, especially ACER's first few booklets. They're a little bit easier than the exam has been lately. It's okay. It's going to give you some experience. And I put the step-by-step work solutions to all of ACER's practice questions on YouTube for free. That's 440 multiple choice questions, step-by-step work solutions. So you can go through those as you go through ACER's practice questions. And of course, the Master Series books by Gold Standard, they're completely updated. They reflect exam questions that have been very recent. Of course, we never repeat the question, but we repeat the reasoning used in the questions. And yeah, there's hundreds and thousands of questions. We also have weekly tutorials, weekly live tutorials. They are starting again in July 2nd, and they're every weekend from July 2nd to the exam in September. And we also do live tutorials every weekend for the March exam, if you're really early. The weekly tutorials are paid. The monthly tutorials are free. So we're also going to have another free monthly tutorial in July and August. We're going to have actually 2 free tutorials in August. And the weekly tutorials, yes, those are paid. And we also have new videos. I can't believe it. And yes, it's AI inspired videos. So AI came out with some unbelievable tools, you know, ChatGPT, and there's so many other companies that came out with some unbelievable tools about 8 months ago. And it's just been growing. And we had all these videos, hundreds of videos. We didn't know how we could, you know, bring them into make them more fun, more engaging. And now it's done and it's all uploaded. So we have these videos. Some of them have animations. Some of them have new practice questions, and all of that is now live on the website. So there's some online things. And by the way, we have a full-length free exam. Did you guys hear that? Is it clear? Because we're the only company that has a full-length free exam. Yeah, not even Acer has a full-length free exam. They have a free test, but it's like half the length of a full-length exam. We have a full-length section 1, full-length section 2, and section 3 with all the work solutions for free on the website. And it will also allow you to see some videos. So you can see some of these new videos that we have, and you can see, I mean, they don't even compare to the ones that we had last year. They've really improved. So I think G has put a link to some of this stuff, and yes, to the free webinars that we have every month, and we have tutorials that are starting again on July 2nd. So you guys are in great shape. You're early. You just did some practice. You got some perspective that many students don't even have. You know, they sit the exam and then they get shocked because of the amount of mathematics. I'll remind you of this on your way out. You know, what students have said, you know, after sitting the exam, so that you have it clear in your mind that you are practicing every day. Do not make the mistake that some students think, that they'll say, I'm not going to practice. I have to study more before I can start practicing. I don't want to practice. It'll affect my confidence. The worst thing to affect your confidence is a GAMSAT score after the exam that was not what you would have predicted. That could affect your confidence. Before the exam, you can trip up, make mistakes, learn from those mistakes, and grow. That's the way to improve it. But you want to be practicing early and often. That's problem-based learning. You learn as you complete problems, just as you did today. So don't think the next time you should do practice problems is in August or in September. The next time you should do practice problems is this week. That's what I hope you get from this experience. Okay, well, that's it for today. Good luck with your studies, and I'll see you guys in the next one. Bye for now.